Hey guys, so now that we have figured out the scale factor and the ratio between all of those, we are going to look at the pattern. So in example one, our scale factor was 2, and then our ratio of our scale drawing area to our actual area was 4. So the first thing I notice is, well, that's multiplied by 2. So then I'm going to check example 2. Does that also go up by a multiple of 2? So my scale factor was 1/3, and my ratio was 1/9. Well, if I was to multiply this by 2, that would just be 2/3, which is not the same as 1/9. So, okay, it can't be by 2, but maybe, okay, I got my scale factor, my ratio of scale drawing, so that's still by 2. Oh, what if I multiplied this one by 1/3? If I multiplied it by 1/3, that also equals 1/9. What if I multiplied this one by 4/3? 4 times 4 is 16, and 3 times 3 is 9. There's a pattern. If you multiply the scale factor by itself, then it equals the ratio of the scale drawing to the actual area. So another way to say that, you guys, is the scale factor can be squared to equal the ratio of the scale drawing area to the actual area. So my ratio is going to be, well, actually, let me erase some of this really quick so that we have some more room to write. Okay, so I'm going to just write over here. So my ratio of scale drawing to actual area is going to be my scale factor squared. So I just have to multiply the scale factor by itself to get my ratio of the scale drawing to actual area. So that's kind of a cool trick. So when you have a scale factor and they ask you, well, what's going to be the ratio of the area of the scale drawing to the actual area, you're just going to square your scale factor and then you have your answer. So keep that in mind as you're working through the problems.